Right now.
Yeah, perfect. Good.
Great. Okay, let's get started. I'll minimize this. Like this. Okay. So hello, everybody. I'm Joshua Waller. I am the DevRel over at Phala Network. And today I'm going to show you Phala Networks as an AI coprocessor and show you how to build these AI agent contracts that we have talked about. If you attended Hong's Q&A yesterday, you got a really good overview of what Phala Network is and the history of Phala Network. So I won't go too much into the details of Phala Network, but this is just like a quick overview of how this workshop will go. So I'll give you an introduction to the AI agent contract. I'll then go into getting started with your first AI agent contract build with the RedPill template. And then we'll transact on chain with the VM SDK with the AI agent contract that allows you to derive key pairs such that you can sign and verify messages and then transact on chain with EVM based chains that are supported by VM SDK. And then at the end, we'll have a question, like a Q&A for any questions that you may have during the demos. So just to give like a little high level look at how I see Phala is a blockchain. We're a blockchain of trusted TEEs, so attested TEEs onto the network, and we have internet connectivity. So with this gives us the ability to create this model called the AI agent contract, such that you're able to build your AI agent contract, compile it, and build this in TypeScript, and then compile it into JavaScript, and then upload it to IPFS. So you can see right here where it has the upload to IPFS here, and then serve that through a gateway such that you can make get and post requests to the AI agent contract from the gateway, which I will show you a little bit later in the details whenever we get to start building. But now you're able to seamlessly publish these AI agent contracts and then serve them such that it's really easy to be able to get a lot of off-chain computation, but also have the security and confidentiality guarantees by the executing within a trusted execution environment on Phala Network. So just to give like another high level of just what I just described as well, is the off-chain storage, which is the IPFS, where your script is going to be published. And then the execution on Phala Network here, which is the trusted execution environment for the confidential compute, such that you can make these get and post requests. So the first template we're going to go over is the RedPill template. So you can think of RedPill as a LLM router, such that you have one API key, and you're able to then choose which model you would like to use with your AI agent contract, and then start to build out your programs utilizing the top LLMs at your disposal without having to have multiple subscriptions. So this is very powerful in this sense. And then also we bring the on-chain aspect to it, such that you can purchase WrapGPT to generate your API keys. And I'll show you the details of that as well in a little bit later when we start going through the workshop. So for those that are following along, I'm going to leave this QR code up here for a little bit. And this QR code will take you to the GitHub repository where the RedPill AI agent contract template is. I'll leave this here for about like 10 more seconds, and then we can get started with the demo. Okay, so I'll go into Phala Network's GitHub repo here. And if you didn't get to use the QR code, you just put in RedPill here in the repository, and you'll be able to find this template here called the AI agent template RedPill. So I'll go here, and you can see that there's a README, and we'll go over this a little bit further. But what I'm going to do first is clone our repo here. And I'll go into terminal. I'll zoom in. First, I'm going to clone. And now I should have my AI agent template. So I'm going to open up my IDE, open project. And here's my template. So I'll open this here, this window. And now we have our template here. So as I went over at the beginning of the presentation, just to give the high level architecture view here, you can see that first we'll be able to build our code, upload to IPFS, and then serve it through our gateway to make GET and POST requests. So, so what I'll do first is we're gonna install our dependencies. So go into my terminal here. And then I'll run, I'm going to use a pnpm, but npm works as well. Pnpm install. So I'm going to install my dependencies. And this will take a little bit of time, shouldn't take too long. And then after we install these dependencies, we'll go on to this next step so that it allows us to test locally, and then also copy over our third web API key. So whenever we do the creating the .env file from the example file, we can look at this example file, and it's a default third web API key that we have created such that you can upload your IPFS agent contract scripts that are compiled in JavaScript to IPFS through this third web account. But if you want to use your own account, you can create a third web account, generate an API key, and replace this value here with your API key whenever if you would want to like handle your own publications to IPFS. So I'll run the next command, which is the cp .env.example space .env. Do that here, and now we have this file created here. So I'll go back here, and then I added a little note. So on getting an API key from RedPill. So if at any time that you see that maybe there is a reply from your AI agent contract that says insufficient funds, please reach out to the Phala team, because this is the default account that is being used. The default API key is rate limited, so we just need to top it up for the developers to be able to continue using it. But if you would like to get your own RedPill API key, then you can reach out to us, and we can get you an access code such that you can create your own API key. So I'll go here to the dashboard for RedPill just to see how this process works. So you can log in with your Google account. So here I'll log in, and I should get to my dashboard here. And this is how your dashboard would look. And this is just kind of like an overview of all the analytics about RedPill in general. So what we'll mostly pay attention to today is the my API portion here. And as you can see here, this is the account that I created. But if I wanted to create my own new API, I would just hit create new API and see the supported models that we have, and then go through the steps to do this. But I'll go back here, and we can see that we have an API URL, we have an API key, we have the usage and the limit. So I have about a limit of 10 million tokens, and the usage I've done so far is 197,000 ish tokens used, and I created this back in May, on May 30th. So some of the things that you can also see here is details. Details will allow you to see the logs of your usage of your API key. So you can see the token cost for the prompt tokens, the completion tokens as well, and the total tokens used per request. And then you can see the wrap GPT cost as well here on this column here. But it also will tell you the model that you used during that query, so you can see the different models that I've used over my time of utilizing my API key. And then also there's a feature here where you can do the chat. You can add different models that we support here, and you can ask a question here and get a reply. So I'll go back to the code base here and just kind of continue on. So if you were to be able to create your API key in this case, the way to change it, change from the default, would be taking this API key here, going into the secrets folder and seeing this default .json file, and then replacing this value with your API key in this case. And if you wanted to say like add multiple secrets to your script, you could also create new files under this secrets folder, new JSON files, and just utilize the same structure to add more secrets. But we'll go into adding secrets to your AI agent contract a little bit later in the workshop. So the next part, I'm going to build our agent. So I'll run pm build. And I've built my AI agent contract now, and you'll see that this folder here in the compiled JavaScript code that will be published to IPFS is here. Next, we want to test locally. So if we look at the test, we'll go into this test file here. What I'm going to, in this test file, I just have like a basic request. It's a GET request. And this is just like a dummy data, like IPFS/CID. And then I'll define my queries. So this query is who are you? I'll define the model I want to use here. And then we can see all the supported models at this link here. So if we click here, you have a choice of all these different models to choose from here. So like some from OpenAI, Anthropic, Meta, Mistral, Quinn, and Google. And then here you will just manually put the API key. So in this case, utilizing the developer API key is easy to use here. You just define your secret here, and then make your request. So we go back to the README. What we'll do is run npm run test. So pnpm test. And here we can see that we got a answer. The message says I'm an AI language model created by OpenAI. And we can see that locally now our test is working. So this is a good sign, but let's see how easy it is to change models. So like I said, we have like a list of models. Let's try a different one here, and we can use the Anthropic model here. I'll replace that here. And then run the test again. So run the test. And then here you can see I am an AI assistant created by Anthropic to be helpful. So now locally we know that if we define the model in our URL queries, we can change the model that we're interacting with. And if we were to say, like, when did humans land on the moon? And then run the test again, and should get an answer here detailing the moon landing here. So that's how you can easily test locally and kind of get started with your agent contract quickly. And if we go back to the README, now we can go into like publishing our agent. So the first part we'll do npm run publish agent. So in this case, I'll do pnpm publish agent, and we should get some output here. So we have the third web and uploaded. So now we have uploaded our compiled JavaScript file. So this file here, the index.js file under the dist folder. And we can see that we have our CID here, which is very important. We have the contract deployment without the secrets here at this at our gateway here. So our gateway is wapo-testnet.phala.network, then /IPFS, and then the CID here of our JavaScript file that's published to IPFS. So in here, we see that if your agent requires secrets, which ours does, we want to make sure to add our secrets to the default.json file. So like I had mentioned earlier, here under the secrets folder, go to here, and then you can add your API key. In this case, we're just going to use the default API key from RedPill that we have for developers to utilize for the demo. So the next step would be setting these secrets, and the ability, if we go to our README here, one other thing to note is whenever you publish your agent, you can see this logs folder get created, and you'll see latest deployment. So if you ever want to know the last time that you published an agent contract to IPFS, this will always hold the latest deployment for you here, the timestamp, the CID, and the URL that you can go to access your agent contract. But we'll go on to the next step, which is adding secrets. So what we can do here is, like I mentioned earlier, is going to the default.json file if you want to add your own personal RedPill API key. And then we'll run, if you just edit the default.json file, then you run this first command. But if you created your own JSON file, then you just define the path to that JSON file where you created your secrets. And then you run npm run set secrets and then the path to that JSON file. So in this case, I'm going to run pnpm set secrets. And now I have successfully set my secrets. And you'll see like the output here where I have like a token and a key and secret set successfully. So here, if we want to verify that the secret was set correctly, what we would do then is if we go down here, we can see this command we want to run is this curl command here. We'll run curl, and then the gateway address, which is wapo-testnet.phala.network, vaults, And then we'll take the key here. So this key here, we'll copy this, add it here, slash, and then token. Do this here, token, and I'll just pipe it into less. And you can see here that this is our API key that has been set for our agent contract for it to consume whenever we're interacting with it. So next step would be making a HTTP request to our agent contract. So here we can see we can access it here at this link. But first, let's kind of look at the code and see what to expect on this first request. So if we go in here into the code's very minimal. It's about 42 lines of code. We have our main function here, and then it routes to the get and post requests. Right now, the post request is not defined or implemented, but we have our get request here. So how we're accessing our secrets from the request is we're accessing this here. So we have our secrets. Rec.secret is how we're accessing them. And then we have our queries. So the queries, like in our test that I showed earlier, like here's our queries, here's our secret, and this is how we're accessing these like in the index file. So from here, we're getting the API key. So first I'm checking to see if the API key is defined or whatever field value that you've defined for your secrets. So I'll check to see if API key exists. If it exists, then I'll grab the API key. If not, I'll just default to the developer API key. And then model from the queries. So now we're looking at queries, and I'll check to see if the model is defined. If the model is defined, then I'll get that model at index 0, or I'll default to GPT 4.0. And then chat query, which would be just the question in this case for the prompt. And it'll default to who are you if it's not defined. So, and then from there, we'll call the RedPill API URL and then define our message here for the chat query from the role of the user, and then define our model here, and then get the response returned. So if we look at where we published our agent contract and added secrets, I'll just click on this link here. And I can see now that I've gotten an answer from my agent, and this is with the default values from our published AI agent contract. But if we want to define queries, in this case, we can do this pretty easily, which I'll do here with the sample question of when did humans land on the moon. I'll go to here and I'll publish this here, but what we can see is that I've added a URL query called chat query here and asked when did humans land on the moon. So we'll enter that and see what the GPT 4.0 will say. So here, this is the answer from there. Next, let's then add another query, because we also have model there, and we can choose a model. So I'll just choose the Anthropic model this time and define that here in the query. So we can see like I did an ampersand and then model equals, and then added the model I wanted to use. And you can see this here. So this is the first template that we're using with the RedPill. And if we go back to our slides, if we go back to this, let me go back to the code real quick. But you'll also notice here whenever I did add my secrets, so whenever I ran the pm set secrets, you can see the secret log as well. So every time that I will add secrets, you'll have a log stamp and a line here where you can see all the secrets that you've added to your script, so that you can always go back and see which secrets are at what URL, and you can be able to access them here. And then another thing is being able to debug your scripts. So if you want to check to see the requests that have been sent to your agent script, you can just run curl the gateway, which is wapo-testnet.phala.network /log/all/ipfs, and then here we'll take the CID, which we can get from here. What was it here? And here we can see like all the requests that we've made. So that last request that we made was when did humans land on the moon, and then the model, and then we saw that we added the check query here and then the default request here as well. So you can kind of see your logs so that you can debug and understand like if there's any errors like in your request to your agent contract that's live. So if we go back here and go to the next template, we can, I'll do this one pretty quickly since we have the basics done, but you can scan this QR code here for the VMSDK template. And I'll just do this for about 10 seconds. And then I'll go into the repo. Okay, so if we look in the Phala network repo, it'd be the AI agent contract -tools. So what I'll do is copy this here, go into my, I'll clone the repo. Great. And then I'll open my repo here, open this window. And we'll kind of go through the same steps in the README. So I'll do a pnpm install. And then the next steps, we'll copy over the third web API key in the environment variable so we can publish a script. We'll then build. Great. And then we're gonna do a test. So we can see like the expected test here where we're going to sign some data with the derived account. But we can take a look here in our test folder, and we'll notice that we have this signed data, verified data, and then send a transaction on chain. And based on this, we're able to do this locally because we've imported this test support. So in this test support, you can see in here that we defined like a global this WAPO so that we can do the local testing of what's expected from deriving a secret. So we call this a derived secret whenever we're deriving a ECDSA key pair based on a salt. So in this case, the salt will be a secret that we add to our AI agent contract. And then there's some other functions as well at your disposal, like hash and choosing which algorithm you would like to choose, a non-cryptographic hash, and then also like a concat UA array. So what I'll do first is execute this test. So here on pm test. Great. And the good thing is that I've added gas to the expected test account that gets derived from this test. So here we can see that we do the signing of the message called Hello Moon, and then next we verify that signature here. So we get the signature here, and then we do a verification step here to get this answer of true. I'll jump into the code in a second to show this as well. And then the next step is doing a transaction. So we were sending 420 GUI to the account here. And we get the transaction hash here. So we can check on base. Oops. We did it on Sepolia. And we can see like 1 minute ago, whenever it was executed and the account and the amount sent here. So we can see that locally this works. If we take a look at the code here, the code's has a little bit more code than the previous example. It's about 131 lines, but we have the main. We didn't implement posts, but we implemented get. So get here, and like I mentioned before with the secrets and the queries, we access these through here. And then we check the secrets for the secret salt. So in this case, the default would be like Salty Bay, but you would define your secrets by defining them here. So I defined the secret salt here with the Salty Bay in the default.json file, but you can choose whichever you would like for your program. And then we define a query called type and another query for data if we're defining any data to sign. So whenever we define the type, this kind of checks our logic. So we see if it's like a send transaction. And then after that, we check to see if to and GUI amount are defined in the queries to then send the transaction. If not, then we'll return a message that missing the queries in the URL here as an answer. And then if we're doing sign, we'll do a sign data. So if we go into this function here, we'll see that we'll get the public key from the account derived. So if we go back here up at the account here, we notice that we call this get ECDSA account with the secret salt. So if we go here, this is where the derive secret function is called. And from there, then we get the private key to account here. And then we use that to be able to send transaction, sign data, and then verify data as well. So whenever we're signing, we use the VM SDK in this case to function to sign message. So whenever we had passed in the data URL query, and then we sign that here with the account.sign message, and then we print out the signature. So whenever we look at the logs in a second, whenever we publish this script agent contract, we'll see this log as well. And then in the verified data, we get the account, the data, and the signature. And this is the logs that we'll see as well whenever we're debugging to see if the signature is valid. So the next step is here, we're going to publish. So we'll do pm publish agent. Great. So we published our agent. Next, we want to add secrets. We can also see the latest deployment here as well with the logs. We'll add the secret. We'll just use the default Salty Bay secret salt in this case. PNPM secrets. And if we want to check to see what secret was set, we can see the Salty Bay here. Great. So now if we go to this link where we set it, and we can also see the secret log here as well. We can go here and we can see derived public key is here. And that's if you just submit the basic URL. What I'll do next is let's just set a new one. So TinTin salt, and then we'll set the secret again. And in our secrets log, we'll see a new line here for a new secret, add a new link. And if we go here, we can see that these derived public keys are different. So, oops. So you'll have two different accounts, and then I know I got about 15 minutes. Okay. So the next step would be if we want to then sign some data. So in this case, we can see that we have a example here. I'll click on this, but more importantly, what I'll do is take this and sign some data. So what I'll do is define my type, and the types that you can have is based on the code we looked at was sign, verify, and SYN transaction. And then I define the data that I want to sign. So I put signed by TEE. If we hit enter here, we can see that this public key signed by TE and generated the signature. If we want to verify the signature, we go back here. We change the type from sign to verify. We have the data, which is the message we signed, and we put an ampersand, and we'll put signature equals, then add that here, and then we can see true is here. But let's see if, let's just like remove like some things here and see if it would say true still. If not, you'll have like an error here. So this case we'll have 3. Signature, perfect. So I'll go back. So the next step would be checking the logs to see what's going on with the request. The curl gateway /log/all /IPFS, and then our CID. What I'll do is go up to our latest deployment, copy the CID, add that here. Nice. So we can see here, is signature valid from the last request we sent, and then the other request where there was an error, say invalid Y parity or V value. So that we can kind of debug and see where the request went wrong as well. And then we have our other requests like the deriving of the key pair. So next we want to then send a transaction. So what we can do here is go back here. We have our type, and then we'll put send tx and see what gets returned here. And like I said, whenever we are missing the query to and GUI amount, we should get this message back. So when we were looking at the code here in a send transaction, before that, we check to see if these two are defined. If not, then we send back this message. So this is correct in this case. So we know that now we need to define a 2 equals, and in this case, I'll just use one of my test accounts here. That, and then it says GUI amount. So we needed GUI amount equals, and then I'll put 420. And this should generate a failure because we don't have enough gas. So we can see that here. Details, insufficient funds for transfer. If we go into our logs, we should also see this as well. So we should see this error as well in any logs that we printed here. So what I can do is take this address, send some funds to it. Well, 0.01. All right, we see that that is successful now. So now we can retry our transaction. So we'll send it here. Nice. So now we have a successful transaction. We can look at the transaction hash here. Paste. And we can see success from the derived key account and then sent to the defined address and then the 420 GUI. And if we go back here and look at the logs, then we can see the logs that we printed out where we get the success, the transaction hash, the information sending with account here, the derived account, and the test account that we want to send 420 GUI to, and then the GET request as well. Yeah, so that kind of concludes the AI agent contract tutorials. Now we can open up for some Q&A for any questions here. And if you would like to learn more, you can go to our docs at docs.phala.network. I also put a link to the GitHub and then the red-pill.ai for RedPill. And then here's a QR code to our docs as well. But yeah, I can take some questions now if anybody has any. And if not, then I can also like kind of show some past examples that people built for the remaining time.
Yeah, right now I didn't receive any questions yet. I think you can show more if you want.
Okay. Some examples, like I just went over this, like where we're deriving a key pair here with one of the AI agent contracts. This is just HTML code that was generated in the previous template, and you could do the same thing that we shown earlier. Different AI and API integrations. So if you think about the AI agent contract, it's really like a fancy like HTTP server. So you can connect to different APIs, and in this case, this connects to in Brian's API, and we have it as well. So if we go to our docs here, um, and you look at AI agent contract templates, I have listed all the templates that I've created over the weeks of different APIs that you can call, or different specialized um, specialized AI models. In this case, like Brian's AI, and then you have like Pond, Alora, and then some very popular APIs like Chainbase, and then also like some example. Oh, there's also like a LangChain template as well. I have an OpenAI, Anthropic, and then an example for like function calling as well. But these integrations are very easy, and you can do them in minutes. So it's just writing a few lines of code to be able to integrate with them. This is the function calling example as well. This one, it'll allow you to go and get the longitude and latitude of where the TE node is, and then also then query about the weather in that area, and then you ask it for any kind of activities you want to do. So in this case, I specifically said what are some activities to do in Austin, and then it gives me like the weather from the weather API, and then the AI will then generate some tasks that I could do while, during that day. Other thing is you can use GPT-4o to like analyze images or any other popular LLM that can do visual inspection in this case. Another thing is our like Agent Wars use case, which was being able to take your Twitter and all your tweets that you've created, and then generate like a little bot that you can interact with, and it kind of generates response like how you would based on your data on Twitter. And then from our one of our hackathons, we did someone did a social engineering white hat agent so that they could use that Agent Wars app, use my Twitter in this case to generate like a phishing link in this case, and then did it on Telegram to be able to like phish the participants. In this case, it was pitched in the hackathon pitching session. So we used like all the permissions and everything to be able to do this, but it was just showing like how easy it is to have these types of agents be created so that you can kind of test your businesses for any kind of you know attack vectors for your social engineering engagements for your businesses. In this case, this one was building your own algorithms called My Algorithms. You're able to upload your agent contract to this to this website, and then be able to then sort your Web3 social based on your new script that you added. So in this case, they added top rated, and it's sorted by top rated. This one was an IDE extension for crypto rewards so that you could contribute meaningful contributions on through their IDE extension, and then you can earn rewards based on some edits that you added, and if it was a meaningful contribution in this case, then you would earn some crypto in this case. So you can kind of like merge that Web 2 and Web 3 types of aspects so that you can create some like unique products. There was another one that was a collaborative token gated pragmatic multi-agent. So they could do like intent-based trading. And here you just create your agents, you combine them together to collaborate together for like a multi-agent system. Then here you could do predictions, info, transactions in this case. So it would also look at the sentiment from like forecasters data. So in this case, you could chat with the prompt and do a prediction. So it would predict the price of wrap BTC over the next hour. Then you could do transactions. So you could say swap 0.001 ETH to link on base, and then using the Brian API, it would generate the extrinsic to sign, and then it would pop up in your application, and then you could sign and do your swap right there. And then you could get sentiment based on social media data about people talking about the token. And then the first place one at the hackathon was someone built Facebook ads on Forecaster. And this is another idea that people can do. So you could generate a URL, you generate an ad, and then you would then generate labels, and it would call the embed API to be able to get the labels from the Forecaster data. And then it would generate these labels here that you can see at the bottom. And then from there, you could reward people. People could claim their royalties from the ads that they created, and then also allowed to pay influencers for posting ads as well. But yeah, those are like some of the examples of what people have built in the past. And since we've added more flexibility and functionality that allows developers to kind of push the limits, now you can do even more with the current AI agent contract implementation with our WAPO.js engine. But yeah, if anybody had any questions from there, then I can answer, and if not, that's all I have for today.
Okay, good. For now, I guess there's no more questions. I'll just show my screen at the end.
Okay.
Quick. Okay. So yeah. It's my QR code. Yeah, here. So yeah. Thank you, Joshua. And today's TinTin Meeting technical sharing session is coming to the end. If you want to know more about TinTinLand, we have other activities coming. You can scan the QR codes from your the most left-hand side, that QR code. Yeah. And yeah, once again, thank you to the guests and friends for your active participation. We will see you next time. Bye-bye. Thank you, Joshua. Thank you, everyone. Bye.
Thank you. Bye-bye.